need to spin up a proxy server for multiple MCP backends without manually configuring each connection. Configuration dictionaries make it effortless. You'll see how to define all your backend servers in a single structured config, then create a unified proxy that automatically mounts each server with proper prefixing. The pattern handles everything from simple single-server setups to complex multi-backend compositions, all while maintaining clean session isolation. From FastMCP, import FastMCP. Create a proxy directly from a config dictionary. Config equals MCP servers. Default, for single server configs. Default is commonly used. URL, https://example.com/mcp. Transport, HTTP. Create a proxy to the configured server. Auto creates proxy client. Proxy equals FastMCP. As proxy, config. Name equals config-based proxy. Run the proxy with STDIO transport for local access. If name equals main. Proxy run. This demonstrates the proxy pattern for MCP servers, creating a transparent intermediary that forwards requests to a backend service. The configuration-based approach abstracts connection details into a declarative structure, letting you define server endpoints and transports without hard-coding them in your proxy logic. What makes this distinctive is how it maintains full MCP protocol compatibility, while completely decoupling the proxy's interface from the backend's physical location or transport mechanism. The pattern works by establishing a dynamic forwarding layer that intercepts all MCP operations, tools, resources, sampling requests, and delegates them to the configured backend. Session isolation happens automatically for each request, preventing context collisions in concurrent scenarios, while advanced features like progress reporting and elicitation flow through unchanged. This creates a clean separation where the proxy handles transport bridging and protocol translation, while the backend remains unaware it's being proxied. This approach solves critical deployment challenges like transport incompatibility, network isolation, or gradual migration scenarios. You can expose an HTTP-based MCP server locally via STDIO for cloud desktop integration, or consolidate multiple remote servers under a single endpoint. The trade-off is added latency for each forwarded operation, so it's ideal for dynamic compositions or access control layers, while static tool imports work better for latency-sensitive applications. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating MCP microservice communication protocol proxies. It provides the foundation for all server interactions, including proxy creation and transport management. Create a proxy directly from a config dictionary. Config equals. This initializes a configuration dictionary for FastMCP server setup. Using a dictionary provides flexibility to define multiple server configurations in a structured way, enabling easy switching between different environments like dev, staging, or production. The pattern mirrors common infrastructure as code approaches for maintainable deployments. MCP servers. This defines the MCP server's configuration key, the root container for all server connection settings in FastMCP. It follows the standard pattern where each server gets its own nested configuration block, enabling multi-server setups with named references. The structure mirrors FastMCP's internal server registry design. Default, for single server configs. Default is commonly used. The default key defines the primary server configuration when only one server is needed. This convention eliminates ambiguity in single-server setups, ensuring the proxy knows which server to target without additional routing logic. FastMCP automatically resolves this key when no explicit server name is provided.
URL https://example.com/mcp.
This specifies the MCP server endpoint. The URL must point to a running FastMCP server instance, as all proxy requests will route through this address. In production, this would be your actual server domain, not the example placeholder.
Transport HTTP.
Specifies HTTP as the transport protocol for MCP server communication. This determines how the proxy serializes and transmits data to the endpoint, with HTTP being the standard for web-based MCP services. This closing brace terminates the nested default server configuration dictionary. It completes the structure for the single server setup, allowing the outer MCP servers dictionary to properly contain all server configurations. This pattern enables FastMCP to handle both single and multi-server configurations with identical code paths. This closing brace terminates the default server configuration dictionary. It finalizes the nested structure containing the MCP server URL and transport protocol, completing the required configuration format before passing it to FastMCP as proxy. This closing brace terminates the config dictionary definition, finalizing the server configuration structure. Without it, Python would raise a syntax error due to the incomplete dictionary declaration. This is standard Python syntax for ending compound statements.
Hash create a proxy to the configured server. Auto creates proxy client. Proxy equals FastMCP. As proxy, config. Name equals config-based proxy.
This instantiates a FastMCP proxy using the server configuration, automatically creating the underlying proxy client. The named parameter config-based proxy identifies this instance in logs and monitoring, ensuring traceability across distributed calls. This is the standard factory pattern for creating FastMCP proxies from configuration objects.
Hash run the proxy with STDIO transport for local access. If name equals main.
This is Python's standard entry point guard. It ensures the proxy only runs when executed directly, not when imported as a module. Without this, importing the file would unintentionally start the server.
Proxy run.
This starts the proxy server, handling incoming requests and routing them to the configured MCP endpoint. The blocking call keeps the process alive, essential for long-running services that need to maintain persistent connections. Without this, the script would exit immediately after initialization. FastMCP Proxy Configuration. Configuration-based proxies let you bridge transports and servers without writing custom connection logic, using simple dictionaries to define remote endpoints. The MCP config schema may evolve, so pin your FastMCP version if you need stability. This pattern turns infrastructure into code, making server composition as simple as defining a dictionary.
The proxy that has no server becomes every server.